Chapter 20 Triangles. Collinear and non-collinear points. Collinear points. 3 or more than 3 points which are in a straight line are called collinear points. For example, A, B, C, D, E, F are collinear points in the given figure. Non-collinear points. 3 or more points which are not in a straight line are called non-collinear points. For example, P, Q, R, S are non-collinear points in the given figure. Triangle. A triangle is formed joining 3 non-collinear points. A triangle is a closed figure made up of 3 line segments called sides. It has 3 angles and 3 vertices. In the given figure, triangle ABC is given. Parts of a triangle. Line segment AB, BC and CA are the sides. A, B and C are the vertices. Angle ABC, angle BCA and angle BAC are 3 angles. Classification of triangles according to the sides. Based on the sides, triangles are of 3 types, such as first, equilateral triangle. A triangle having all the sides equal is called an equilateral triangle. In the given triangle ABC, line segment AB is equals to BC is equals to CA is equals to 3 cm. Therefore, triangle ABC is equilateral. We also find that angle A is equals to angle B is equals to angle C is equals to 60 degrees. Thus, all the angles of an equilateral triangle are equal, each measuring 60 degrees. Second, isosceles triangle. A triangle having 2 sides of equal length is known as an isosceles triangle. In the given triangle PQR, PQ is equals to PR. Triangle PQR is an isosceles triangle. Now measure angle Q and angle R. We get angle Q is equals to angle R. Thus, the angle opposite to the equal sides are equal. Third, scalene triangle. A triangle having all sides of different lengths is known as a scalene triangle. In the given triangle XYZ, XY, YZ and ZX are different in measures. So, triangle XYZ is a scalene triangle. Also, all the angles of a scalene triangle are different. An important result. The sum of the lengths of any 2 sides of a triangle is always greater than the length of the third side. Verification. Consider 3 triangles, triangle PQR, triangle STU and triangle LMN as given below. Measure the sides of each given triangle and fill in the table given below. Possibility of forming a triangle with sides of given lengths. We can form a triangle only when the sum of the lengths of 2 smaller line segments is greater than the length of the longest one. Therefore, in any triangle ABC, AB plus BC is greater than CA. Example 1. We are given the 3 sides AB is equals to 2 cm, BC is equals to 4.3 cm and CA is equals to 5.5 cm. We need to check whether the triangle can be formed or not. For this, the given sides are AB is equals to 2 cm, BC is equals to 4.3 cm and CA is equals to 5.5 cm. For a triangle to be formed, the sum of 2 sides should be greater than the third side. Let's check. Firstly, AB plus BC is equals to 2 cm plus 4.3 cm which is equals to 6.3 cm which is greater than the length of CA. Now, secondly, I am checking these 2 sides BC plus CA that is equals to 4.3 cm plus 5.5 cm which is equals to 9.8 cm which is again greater than the third side which is AB that is 2 cm. And thirdly, let's check the sum of AB and CA. So AB plus CA which is equals to 2 cm plus 5.5 cm which is equals to 7.5 cm which is again greater than the third side which is 4.3 centimeters that is BC. Hence, we can say that the triangle can be formed. Classification of triangles on the basis of their angles. There are 3 types of triangles with respect to their angles. First, acute angled triangle. When all the angles of a triangle are an acute angle, that is less than 90 degrees, it is known as an acute angled triangle or simply an acute triangle. For example, in given triangle ABC is an acute angled triangle as it has all the angles less than 90 degree. Second, right angled triangle. When one angle of a triangle is at right angle, that is 90 degrees, it is known as a right angled triangle. For example, in triangle PQR, angle Q is equals to 90 degrees. Hence, it is a right angled triangle. Third, obtuse angled triangle. When one angle of a triangle is an obtuse angle that is more than 90 degrees, it is known as an obtuse angled triangle. For example, in triangle ABC, angle B is equals to 100 degrees, which is greater than 90 degrees. Therefore, it is an obtuse angled triangle. Angle sum property, an important result. The sum of all the angles of a triangle is always equal to 180 degrees. Verification. Consider three triangles, triangle ABC, triangle PQR, triangle XYZ as given below. Measure each one of the angles of the given triangle and fill in the blanks in the given table.
Example 1. In triangle PQR, if angle P is equals to 55 degrees and angle Q is equals to 80 degrees, find angle R. So, we know that according to angle sum property of a triangle, sum of all the angles is 180 degrees. Hence, here in triangle PQR, angle P plus angle Q plus angle R will be equal to 180 degrees. Here we are given that angle P is equals to 55 degrees, angle Q is equals to 80 degrees, and we need to find the measure of angle R. So it is 55 degrees plus 80 degrees, angle R as same. So angle R is equals to 180 degrees minus 55 degrees minus 80 degrees, which is equals to 180 degrees minus 135 degrees, which is equals to 45 degrees. Therefore, angle R is equals to 45 degrees. Example 2. Can there be a triangle whose three angles have the measures 50 degree, 45 degrees and 90 degrees? For this, firstly we need to check the sum of these angles. Sum of the given angles is equals to 50 degrees plus 45 degrees plus 90 degrees, which is equals to 185 degrees. Now you can see that the sum is coming 185 degrees, which is greater than 180 degrees. And we know that according to angle sum property of a triangle, the sum of all the angles of a triangle should be 180 degrees. And if it is greater than or less than that, then there is no possibility of it being a triangle. So, the sum of three angles of a triangle must be 180 degrees. So, there cannot be any triangle with the given measures. And this is how you should do this question.